two reasons why we look at how to compute the 2 norm of a 2 by 2 diagonal matrix. The first is to show that for some matrices there's a simple formula for its 2 norm. And the second reason is that it allows us to illustrate a proof technique that is going to come in handy when we deal with proofs that involve norms. Okay, so let's look at this. Well, first of all, we're going to square the 2 norm of the matrix, because then we don't have to deal with the square root all the time. And that's just equal to the max over all vectors with 2 norm equal to 1 of the 2 norm squared of the matrix times those vectors. Now, we can multiply out the diagonal matrix times the vector to get this, and then we can use the definition of the 2 norm to get that it's the sum of the squares of the elements, or the absolute values of the elements. And then we can factor out the delta 0 and delta 1 in absolute value squared. And finally, we can say, well, if we take the maximum of those, then we can factor that out. We can bring it outside the first max, and then we can recognize that the max over all vectors with 2 norm equal to 1 of the 2 norm squared of that vector is just 1, and that gives us that the 2 norm of the diagonal matrix squared is less than or equal to the max of the absolute values on the diagonal squared. And that's the conclusion that we show here. Now that just shows that it's less than or equal to. We want to show that it's equal to. So what we're going to do is we're also going to show that it's greater than or equal to. And how do we do that? Well, here's the 2 norm of the diagonal matrix. We apply the definition. And now if we choose a specific vector x with 2 norm equal to 1, then we know that it's greater than or equal to. And the standard basis vectors are convenient to pick. So here we happen to pick the standard basis vector 0, 1. And if we then just multiply it out, then we can bring out the delta 1, and then we can bring it outside. And then we find that that just gives us the absolute value of delta 1. Now, we could have picked the vector 1, 0 or the vector 0, 1. Depending on which we pick, we would get the absolute value of delta 0 or the absolute value of delta 1. And therefore we conclude that the 2 norm of the diagonal matrix is greater than or equal to the maximum of the absolute values of the diagonal elements. Now, we really should have been a little bit more precise. What we could have said is let's pick J to be the index of the diagonal element that has the maximal absolute value. And then we could have said, okay, the 2 norm of the diagonal matrix is equal to the max. It's greater than or equal to the case where you pick a specific vector, and that happens to now be the standard basis vector that corresponds to the diagonal element that's largest in magnitude. And then we can just push that through to find out that we get the absolute value of the diagonal element that we said was equal to the maximum of the absolute values of the diagonal elements. And therefore we conclude that the 2 norm of the 2 by 2 diagonal matrix is also greater than or equal to the maximum of the absolute values of the diagonal elements. And then we know that if it's both less than or equal to and greater than or equal to, then it must be equal to. So in the future, we're often going to use a slightly different proof technique. And that proof technique is to say, look, if we're given a function from a domain D to the real numbers, and we want to show that the maximal value that that function takes on the domain is equal to alpha, then a strategy is to first show that it's less than or equal to alpha, and to then find a vector y in the domain such that f of y is equal to alpha. And from that, then we can conclude that the maximum value attained for any element in the domain is equal to alpha. So how would we employ that here? So in the first part of the proof that's just repeated here, what we did was we focused on the definition of the 2 norm, and then we showed that it was less than or equal to the desired result. That's our alpha. We then said, okay, we can find a specific vector for which the alpha is attained. Okay, so here what we said was, well, if we pick the standard basis vector that corresponds to the diagonal element that's maximal in absolute value, then the function is equal to alpha, where here alpha is equal to the maximum of the absolute values of delta 0 and delta 1. And therefore we can conclude by what we just discussed that the 2 norm of the diagonal matrix is just equal to the maximum of the absolute values of the diagonal elements. And that's a proof technique that you're going to see over and over again in proofs that you'll do in homeworks in the future.